I already made this thing here, but the old one was capable of only 300 volts DC. It was stupid, and I thought, considering that I used this thing so many times, why not making it again from scratch, maybe improved, more powerful, and with a dedicated transformer? So what are the specs of this power supply here? Okay, it's capable of like 420 volts at open circuit on the output, adjustable here, sometimes even a bit more. And it's limited at like 250 milliamperes with an electronic system for various reasons. It has a voltmeter here, full scale 1 kilovolt, but it will read obviously a maximum of 420 volts. It's fully insulated from the input here to the output because there's a true transformer inside. The regulator is linear, but it's not stabilized, maybe just a bit against ripple, and it's inside a box of an ATX power supply for convenience, obviously. Okay, the transformer. I wound this thing myself. Okay, it's an insane chore, a lot of work, but I'm becoming good at winding transformers, and I save money, obviously, because throw that away. Anyways, I just kept the original mains voltage winding here. The transformer comes from a computer UPS, a medium-sized one. I wound the 300 volts winding on these wires here, and another insulated, separated winding of like 7 volts for the supply of the voltmeter. And another thing, the 300 volts winding is outputted here on this connection, easily detachable, because I want to maybe reuse the transformer as AC output for maybe a tube amplifier. I don't know, I don't want to purpose an entire transformer for just one thing. And for the regulator, I used the schematic I found online. It seems to be kind of an old schematic, but it's easy, few components. It uses a MOSFET as sort of emitter follower. I just slightly improved, in my opinion, the schematic, raised the voltage, raised the current, and used maybe a bit chunkier MOSFET than suggested. And about the voltmeter. Okay, I ordered this voltmeter online. It costed €1.50, something like that. And it was for a maximum of 100 volts full scale, and I thought it would do 99.9 volts, and under 10 volts, 9.9 volts. No, it does under 10 volts 9.99 volts with sense here, and it moves the dot on the original display from here to here for above 10 volts. So with 1 kilovolt, because I added a like 1 mega ohm resistor in series of the input to make it 1 kilovolt full scale, the dot is not displaying the right spot of the decimal. So I had to obscure the original dots on the display, on the original display, and put an external LED here that you see, and it is connected on the pins that light up this spot, this dot here. And I had to kind of reverse engineer this display, this voltmeter, because the display is Charlie plexed, not multiplexed, so it's even more complex, just 6 pins on the display, and I put the LED here that is kind of visible, not much, but yeah, when it's below 100 volts, it's 99.9 volts, and above 100 volts, it's hundreds, tens, and units in that case. And I added the thermal switch on the heatsink here near the MOSFET. This switch is rated for 105 degrees Celsius, obviously, and it should trip when the MOSFET dissipates too much power and the heatsink reaches that temperature, and it cuts the transformer primary because it's the safest spot to cut the power, and there is a ceramic capacitor across the contacts because the switch is intended for resistance resistive loads, not inductive loads. Anyways, the MOSFET will probably dissipate even more than 100 watts when it's in short circuit on the output for a fail, something, a fault or something like that. So the heatsink must be big, and possibly there must be also a thermal protection. Okay, let's try this thing. Simply voltage output reading on my multimeter here, no load. Let's turn it on. Okay. And you see the display with the decimal dot. Okay, let's see. Okay, 16 volts. 85. The still decimal dot. Kinda reliable in voltage. More. Now we are above 100 volts and LED turned off. 153. Okay. 248, okay. 304, okay. My multimeter is reliable in reading, and with the current mains voltage we have 427 volts DC, and that's okay. It's a bit slow at going down in voltage because there's no load, obviously, and capacitor charge just with high value resistors and such, but you know. Okay, now let's try with a load. We have here a beautiful 25 watts light bulb, nothing special, filament obviously. And let's turn it on. Okay. Let's rise voltage, 20 volts, nothing. 47, nothing. Okay, at kinda 60 volts with the naked eye, kinda 20, 55. I can see some light. Okay, 110. We are not in the US. More. Okay, I think that exposure. Okay, now we see better the display. Okay, let's adjust it at the correct voltage for the light bulb. Okay, and it goes a bit up and down with the voltage because my mains isn't stable, sadly. Okay, let's do something daring. This. Woo! 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 Okay, the light bulb is surviving. $399, I believe. Okay. Okay, now let's see the short circuit protection current with this multimeter here, full scale 250 milliamperes. Luckily, let's say luckily. Anyways, now the power supply is under my variac at a lower voltage. Why? Because I don't trust to let the MOSFET dissipate more than 100 watts at the moment, so I'll reduce the voltage, but the current will be the same. Anyways, let's turn this thing on. Okay. Now the voltmeter doesn't light up because the supply voltage on it is too low, but the system is working. If I rise the voltage, you see, it already goes at protection current, and if I move the voltage, it doesn't do anything. It's already at maximum. You see? And yeah, theoretically, when there is a full mains voltage on the power supply, it will dissipate like more than 100 watts on the MOSFET. The MOSFET is kinda chunky. It's fake, actually, but it should withstand that power, but at the moment I don't trust it. And sorry for this connection here, because this alligator clip sucks. And this is the original schematic that I found online. Okay, it's a sort of emitter follower system with a MOSFET. It's an IRF 740, and it's like 10 amps, 400 volts, not a chunky one. Maybe I have a plastic one, a pair of these, and it suggests a 1:1 ratio transformer for like 300 volts. And there is an electronic protection, no capacitors on the output. Not important in my opinion, but whatever. But let's do a thing, because I feel that much better. When it's black and white, it's art. You can take a picture of a dog's turd, make it black and white, and it will be art. That's how it works. Anyways, it's due for an electronics schematic to be black and white, in my opinion. Colors are just, I don't know, a punch in the eye. Anyways, these are also the modifications that I made. I added this capacitor here, kinda half for micro. You can use an MKP X2 one here. It's kinda rated for 630 volts at the end. And I split the resistor. It was mandatory, complex to explain. And this capacitor avoids a bit of ripple on the output coming from the supply here. I also added this resistor here. Not vital in my opinion, because I feared that when you short the output there may be a peak of current on the base of the transistor, because this resistor is so low. It could ruin this BJT, but maybe not at the end, because the MOSFET will instantly cut the current and it will not happen, but I didn't trust that at the end. And some capacitors on the output, again maybe not important, and 300 volts AC secondary on the transformer, same diodes, same electrolytic capacitor, but must be rated for 450 volts DC. This resistor is now 2.2 ohms for more current. I used a chunkier MOSFET that was supposedly an IXTP 460, but it wasn't, it was fake, and that's basically it at the end. So thank you for watching my video, and as always, if there are updates about this project here, you'll find them down in the description of the video. Okay, at this point I think goodbye for now. And we all know that unhealthy lifestyle is important, and we should all listen to like nutritionists and brainwashed people online.